Hello, welcome back to Cracking the Cryptic. And after the excitement of yesterday with Simon's hole-in-one on a par 4 and my having a selfie request, well, I was going to say today's a more ordinary day, but actually this puzzle commemorates why it's not. I will get to that in a moment. First of all, I will say that we are now within 17 hours, I think it is, of the deadline on our Patreon reward content for the month, the PBN Institute puzzle packs, both carrying prizes, and we thank Panthera, Grockles and the Asylum for creating those. They've been very popular. You do still have a few hours left. It closes at 4 PM our time tomorrow. By special request, somebody asked, what is this Eastern Standard Time? I think it's 11 AM tomorrow, or on, well, I mean, I will say on Monday, 11 AM this time. So that's Eastern Standard Time, but 4 PM UK time. Wherever you are in the world, hopefully you can work out what that is your time. But anyway, many have already sent in their solutions, and patrons will also be aware of Sam Kavanagh Johnson's classic puzzle, which Simon explains the trick in after watching me solve it without knowing it. That's worth a look, perhaps. And on the channel, we've had an Annex Cryptic crossword recently, and also Woofers EFG's brilliant explanation of the amazing puzzle adventure from the Galactic Puzzle Hunt 2018. Also worth a look, I reckon. But the links under the video will take you to our apps, to our merchandise, to Sven's SUDOKU PAD, the catalogue of our puzzles, the Discord server, how to join Patreon, and so on. But the first link is to this puzzle by Prime Weasel. Now, what is 414 doing in the grid, and why is it special today? Well, this is explained in Prime Weasel's original full flavor text preamble, which I will go through now. So when A equals 1 and D equals 4, those are the alphanumeric values, obviously, of A and D, then 414 equals Dad. And this is a Father's Day puzzle, effectively. A fully filled Sudoku grid, Prime Weasel goes on to say, sums to 405. So he's really dropping a knowledge bomb on us there. That is true. But 4 plus 0 plus 5 equals 9. When you add this 9 to the 405, you get 414. That's what Dad does. He makes it work even though it doesn't make sense. You don't question Dad or how weird his rules may be. And 4 plus 1 plus 4 equals 9. So there you go. Yeah, okay. This may be like the relationship a lot of us have with our fathers, or if we are fathers with our children, where Dad is not to be questioned. Anyway, so what are Dad rules, says Prime Weasel. Besides the normal Sudoku rules, there are killer cages. These killer cages sum to either 1, 4, 14 or 41, and digits can't repeat in them. So we're still using these digits 1 and 4. The grey highlighted 4s are separate regions which sum to 45. Well, they're 9 cells long, so that's another knowledge bomb. Because, but he says because 41 plus 4 equals 45. I see. So 41 plus 4 equals 45, so that's what the grey cells add up to. Or the grey 4 shapes. The 1 shape adds up to 14 plus 4, which is 18. So that total is 18. These are separate digits which add up to 45. They're extra regions, effectively. And what else do we have here? There's more. Oh yeah, the white dots. Now these are not the normal white dots you would expect to see. Within cages, white dots appear whenever there is a difference of 1 or 4 between two adjacent cells. These white dots are only found within cages, not between cages, and in this way there's a negative constraint for the white dots. I hope you like Dad and that he's not too tough on you. Well, there we go. That is the introduction from Prime Weasel. So just to run through these rules again, I've condensed them in the version of the puzzle you get if you call it up in our software, which I do encourage you to do. Normal Sudoku rules. Digits don't repeat in cages, which sum to 41, 14, 4 or 1. The 2 grey 4s each contain no repeat digits and sum to 45. The grey 1 sums to 18. Whenever two neighbouring cells in a cage have a difference of 1 or 4, like these two, there's a white dot between them, but any two cells within a cage that don't have a white dot don't have a difference of 1 or 4. And we don't know anything about two neighbouring cells that are across cages. So those are the rules. Give it a try. There's a lot of information here, so you could go about this puzzle, I would say, in a lot of different ways, but I'm going to try my way, and I'm going to start now. Let's get cracking. So let's start with the one cell cages, because they obviously have to be 1s or 4s. That is a fairly simple sum to do. So I've found 6 of them. Have I missed any? Can't see it. Now, the 2 cell cages, they could add up to... Okay, well this one can't add up to 4, because 4 would have to be made of 1, 3, and there's already a 1, 4 in this box. So that one has to be... Well, it has to add up to 14. Ah, here's the negative constraint straight away. This cannot be a 5, 9 cage, because the 5 and the 9 are 4 apart and would have to have a white dot between them. So it must be a 6, 8 cage. Ah, look, this is a 2 cell cage, and it can't be 1, 3 because they wouldn't get a white dot between them. Same's true of 6, 8. So this one is a 5, 9 cage. So that's got to be true here as well, I think, in this 2 cell cage. Doesn't that have to be... Yeah, that has to be 5, 9 as well. I'm just checking the logic. That's right. This one we don't know. This is either 6, 8 or 1, 3. This one the same, I don't think we know. And that ends the 2 cell cages. 3 cells are much harder to determine, I think. There are so many combinations. But the other size of cage we get... Oh no, we've got some 4s. We've got 1. Have we got any other 4 cell cages? No, just 1. Well, that must add up to 14. It can't reach 41. Yeah, I think all the 3 cell cages actually are going to have to be 14. They can't be 4s. So all the 3 and 4 cell cages add up to 14. But there are also some 8 cell cages. Might be a 7 somewhere. I think this is 8. This is 8. This is 8. This is 8. And I think, no, I've got an extra digit. That is 8. 5, 7, 8. Yeah. So those are all... Right. Those don't have 4s in. Right. How do I know that? Because the sum of the digits from 1 to 9 is 45, which was sort of mentioned in the rules. If we have an 8 cell cage that adds up to 41, I mean it can't possibly be 14, 4 or 1, then that's using all the digits except 4. Ah, so that's very interesting. So none of these digits can be a 4. So where's the 4 in this box? It must be in one of these 2 cells. What else can we do like that? Yes, where's the 4 in this box? Not in those cells, so it must be in one of these 2. Just want to keep going on this theme. None of those can be a 4. So the 4 in this row must be in one of those 3. Ah, right, yes. None of these cells in both of these 8 cell cages can be a 4. So where's the 4 in box 9? It's clearly in the middle of it. And where's the one in box 8? Once you've put a 4 in there, you're going to have to put a 4 here as well. So both of these are 4s. So that gives us a 1 in a cage. That gives us a 4 in a cage. It doesn't sort out this pair. Right, also, here's an interesting thing. 4 can't be in those cells. Oh, I could have done this 4 straight away from noticing that this was an 8 cell cage, which I didn't notice. Don't know how. Maybe because it's straight, it eluded me. Anyway, that was always going to leave a 4 in the row, so I should have spotted that straight away. Well done if you got there quicker. Anyway, what I have now noticed is that none of these can be a 4s. Ah, that's interesting. This is... Well, no, it's not necessarily a run of 3 digits. In fact, it can't be, because 14 is not divisible by 3. What am I on about now? Anyway, I know there must be a 4 in it, because there can't be a 4 in these cells in box 1. And box 1 needs a 4. So it's got to be in here somewhere. Now, 4 must connect to another digit, which is either 4 or 8 away. If it was connecting 4 away. You would have a 4 and an 8 in a cage that must add up to 14. And the other cell would be a 2, but 2 cannot connect to either 4 or 8. It's 2 or 6 away from them. So this 4 doesn't connect to 8 wherever it appears. It must connect to either 5 or 3, which are 1 away. Now 4 and 5 would need another 5 in the cage to add up to 14, so that's not what happens. This must be a 3, 4, 7 cage, and the number in the middle of the two joins must be 3, which is 1 away from 4 and 4 away from 7. So we get a 3 there. And this is a 4-7 pair that I can't actually disambiguate, but oh, that's quite interesting though. We've got a sort of X-wing on 4s. Because we know 4's in one of those two positions in row 6 and one of those two positions in box 1, that's using up the 4's in columns 1 and 2. So now in this box, 4 can't be in any of those cells, and with the 4's we've placed in row 8 and 9, it can't be there. So actually this single cell is a 4 now, which doesn't really help, or does it? Look, we've worked out that all 4 and 3 cell cages add up to 14. So that group I've just highlighted adds up to 42. Plus the 4 there is 46. Now this cage either adds up to 4 or 14. If it added up to 4, is this right? We would have a total of 50, but we can take out this box of 45. Every box adds up to 45, remember, and these cells I've got highlighted would have to add up to 5. If I've done this right, let me just think about this again, and I'll do it the other way now. In fact, I think that means it can't add up to 4 in the corner. It must be another 14. So that's 4 sets of 14. That's 56. Plus that 4 is 60. Now we can deduct 45, being that box. And the cells I have highlighted must add up to 15. They've got 2 4's in already, so we need another 7. Well, that can't be a 3-4 combination, or 4 would double up. And it can't be a 2-5 combination because there's no dots in this highlighted area. 4 next to 5 would get a dot. So it must be 1 6 to make up this total of 15. So that's a 1 or a 6. And up here 4 is with 1 or 6. Now, oh, that's lovely. Yes, that can't be a 6 because this cage adds up to 14 and that would need another 4 in it to make the total right. So that's a 1. Here we have a 4-6 pair. This is a cage that adds up to 14 as well, so it now needs a 1 and a 3 in it. They must go like that. This cage has to add up to 14, so it needs a 9. Then this adds up to 14, and it's a 6-8 pair, which actually we knew from the logic about not having a dot in it like there. And this must be 2, 5, 7. Now, do any of those numbers have to be kept apart by the rule? Not really, actually, no. So, not to worry about that. Now, that's given us an X-wing on 6s here. To go with our X-wing on 4s, I don't know how to use that. What about this column? 1, 3, 5, 9... No, I don't really know what's going on there. Okay. Oh, I must know what this cell is because we have 41 in that cage, 41 in this one. That's 82. Plus the 2 4's is 90. Plus that 1 is 91. And this is 2 boxes worth add up to 90. So that is the leftover 1 there. So that makes this a 4. That makes this a 1. That places 4 in this box. Now, this is a 14 cage. If it was 4, 8, that would be a 2. Oh, that is possible this time. If it was 4, 3, that would be a 7. And if it was 4, 5, that's impossible at least, because this would need to be another 5 and a repeat. So this is, what did I say, 8 or 3. And this is 2 or 7. 1 joins on to either 2 or 5 here. Now, if it was a 5, since it couldn't be joining on to 4, it would be joining on to 9 and 6. If it was a 2, it would be joining on to 3 and 6. Interesting. I don't think I can really finish that off. Okay, I'm going to have a think about this shape. And I'm going to compare this shape with this box. Yes, this is important. This shape has the numbers from 1 to 9, not including 4. So somewhere in it there's a 6. And that 6 can't be in this box because there's already a 4-6 pair. Now the same is true for whatever number this is. 5 or 9 must also be in this pair of cells. So 6, 9 wouldn't get a dot, so it must be 6, 5, and that 6, 8 pair even tells us which way round they are. That also tells us that we have a 5 there. So now we are moving, I think. 5, 6, 4. Now I probably know what this is from the grey shape. The grey shape has already used 9, 6 and 4, so it can't have another 9, 6 or 4, but the box needs one of each. It's got a 4, 6, it needs a 9 there. So the law of leftovers is being quite useful here. Now, can I do any more? That's not a 5. This is now a 1, 2, 8 triple. But 1 and 2 can't touch because there's no dots here. So 8 is the chaperone keeping them apart. Oops. And then we can place the 2 and 1 thanks to this. Now 8 there, right, that's sorting out the 6, 8 pair. That's sorting out the 6, 4 pair. Yeah, there are a lot of ways to get into this puzzle, but it's very neatly done. Now, 2, 7 and 9 on that row. How's this 14 cage made up? 2 and 7 would need a 5 here, but that couldn't join on with a dot to 2 or 7. So it's not 2 and 7. Is it 2 and 9? Yes, if that was a 3, that could join on to 2. Is it? It can't be 7 and 9, that's far too many. So it is 2 and 9 with a 3 here joining to the 2. That's a 9. This, oh well, there are 2, 4, 8 and 5 left in this row, which add up to 19. We have to take 14 away to get this digit, so that's a 5. These are 2, 4 and 8. Which two of those join together? 4 and 8, actually. They're the ones joined together. This is coming very nicely now. So here we have a 3 and a 9. Now 9 could put a 5 here, or 3 could put a 7. I think that's all that can be. Oh, well, this is a 5, 6, 7 triple, so that was another way of knowing 6 would be on the dot. This can't be this can't be no, I was going to say this can't be a 5 or a 6. Actually, I only know it can't be a 5 because the white dot applies within the cage. So that's 6 or 7. I don't think this can't be 6, or there would be a white dot next to 5 or 7. So that's a 5, 7 pair. This is 6. And I don't know how the rest of the row works, surprisingly. That 2 has made this a 7. That can't be a 3. Now, this is in a white dot relationship with 2 cells. If it's not impossible to be a 9, except it is now, because that can't be an 8. 9 would need 5 there and 8 in the other cell. It's very odd for a white dot to be a possible 9 for me in between 2 other white dots, because they would have to be normal. In normal Crocky, they would have to be both 8s. But of course, with the 4 relationship being available, in theory, you could have a 5 in one of those. But anyway, it's not a 9, it's a 6. This is therefore, oh, I don't know. This could still be 2 or 5. That's not 6. This also is 2, 5 or 7. Which gives me a triple in the row. Oh, here's a law of leftovers thing. This box needs all the digits apart from 4. But it can't, in these cells, use any of 8, 6, 9. So they're a triple up here. And that is exactly what I've proved by finding the 2, 5, 7 triple there too. So that was a bit pointless. Now, this cell sees 6 and 9. It's a naked single 8. Sorry, pardon me. Oh, look, I've got a 3 looking at that. So that's 9. This becomes 5. This can't be 5 anymore. These two need a 3. That's interesting. Both 3 and 6 can combine with 2 and 7. But that 2-7 pair gives me a 5 at the top, gives me a 9 here. That's a 2-6 pair. Oh, we've got cage totals all over the place. Right, this now is a 14. Oh, this is a 2-cell cage I never spotted. That's a 6-8 now. Oh, there's loads of information to finish off now. I think we are going to be fine. 7 in this cage is done. In fact, the whole cage is done. Now I can finish off a couple of eye wings there. This is a naked 8 with a 2-3 pair, but we could use the negative constraint. 6 can't be next to 2 within a cage unless it has a dot. So this is a 3-8 pair. This is a 6-9 pair. Which of those can combine on the dot? 9-8 only? Yeah, I think so. This cage needs a 2 and a 1, and that all looks like it works around the dots. 6-8. So this isn't too taxing. Ah, this is next to the 5 and has a dot, so it's a 9. 7 there, 5 here. This is a 1, that's all it can be. Now that would have a dot next to a 2, so it must be 7 there. 2 to finish the row. This is a 9, that's a 6. 3 is 4 away from 7, which is 1 away from 8. And there we go. That is the Dad puzzle by Prime Weasel. That's good fun. Lots of ways of getting at that, I think. I suspect I just selected one of them. But very clever to make that work with all the 4s and the 1s connections. And a suitable puzzle for Father's Day. Happy Father's Day to all of you out there. And hope to see you again soon on the channel. Bye for now.